All right. So thank you for the introduction. I do appreciate it. And looking across the room here, I do acknowledge the fact that I believe I'm a speed bump on your way out of here, possibly. On the last speaker, you know, it's whenever they put you on the last slot, you're like, wow, maybe they put me there to anchor the conference. Or they're like, hey, we really don't want to hear this guy talk, so let's just throw him at the end of the day. Maybe he'll get, you know, a few people in there. Anyways, I do appreciate the opportunity to speak to everyone. I do appreciate everyone's time here in the room, because I do know you had decisions to make across the talk, so I do appreciate the time you're going to devote to me here. So I'm spending the next 45 minutes to kind of talk about my research here. And this talk is called Who, When, Where, and a Cheap Hardware Solution to Develop Pattern of Life. Additionally, I'm going to talk a little bit about the lessons learned while conducting this research. Because again, I started off with a great idea, and as I kind of unfold this in front of you, we might laugh, we might cry, or you may laugh, I may cry, but we'll see, we'll get there, right? There are a lot of lessons I learned here en route to this. Before I kick off, I just want to mention kind of my process here was typically I kind of build a whole idea, and then I get to the point where I want to present it in a talk conference. This one is a little backwards. I took a friend of mine's approach to challenge development, and he picks a name first, and then he writes a challenge around that name. And so that's when I kind of went here thinking, this is a great idea. This has got to be a new avenue for people to approach with hardware. I learned a lesson here, and so I'll kind of share that with you as we go. So this is the agenda. This is kind of my talking points here that I'm going to cover. I'm going to tell you a little bit about me, and that's not really the grandiose piece. That's just so I can kind of let you know like where I come from and why I'm approaching what I'm doing here. I'm going to talk a little bit about the why, right? Essentially, you know, I identified a problem, and I wanted to kind of solve this problem. Then I'm going to dip into the design process that I use to kind of get after this and kind of dissect the problem. Some of the unique technologies that are both old and new in this particular talk. I'm going to talk my development process, show you a demo, then we're going to talk lesson learned, and then kind of future work. Close it out with like, hey, I know I stumbled a little bit in my research. I know I stumbled a little bit in the application of these ideas. However, I do see some avenues where I can go ahead and take this to the next level. Before I jump into the meat of my slides here, I do want to say I like to keep it marginally interactive, so don't think, so if you have a question, please raise your hand while I'm in the middle of the talk. I would rather address the question in the context of the information I've already presented. That way we can all learn as we go. So don't think you need to wait until the end of the end of my talk to go and ask a question. I don't mind being interrupted. Yes? Okay. Perfect. We got an alpha card for Wi-Fi sniffing and a practical IoT hacking on theme for this talk. I appreciate it. Fantastic. All right, so a little bit about myself. Josh Rykowski, at Ryko212 on the Twitters there. First and foremost, I'm a husband and father of 4. I am a cyber officer in the Army, as you kind of seen this theme here. You heard Alberto earlier. He was a prior officer. I do a lot of programming in my spare time. Focus a lot on Python. I am one of the executive directors and founders of the RunCode.Ninja Programming Challenge nonprofit. We are going to be running a competition here in November. If you're interested, check it out on RunCode.Ninja. And then with my copious amounts of spare time, I do like to spend some time reviving old technology, right? So I revive 1980s technology, and I also collect 80s and 90s video games. For those of you, that's like the Atari, ColecoVision, and Television, going way back, the stuff you kind of see in museums nowadays. And then all the way there at the bottom in the fine print, just know that kind of the views and everything I'm talking about here do not represent the views of my employer. I just got to throw that out there. No official policy. This is all research conducted in my spare time. So just kind of keep that in mind as we move through here. All right, the why. So before I start to do the research, before I start to do the development, what I need to do is kind of a little bit of a gap analysis, right? And so that gap analysis is really taking a look at what I can do, or sorry, what I want to do, and then compare that to what I actually can do, right? And that intersection, hopefully, in a perfect world, that's a Venn diagram, right? And you have a little intersection in the middle there. You're like, this is what I want to do, this is what I can do. I'm going to live right there in the middle and focus my research there. Sometimes it doesn't work that way, sometimes it does, but that's kind of where I start when I do my research. So in this particular instance, what I wanted was I wanted to prove individuals were on the network. And then I thought, well, how can I actually do that? Well, I can sit out, I can sit in the parking lot of my car with a camera and take pictures, and that's only just a tad creepy. But I'm like, well, wait a second. I do like to do a little tinkering. I do like to build small devices. I do some Wi-Fi research on my own. I'm like, wait a second. Maybe I can prove people are in the network by just saying I'm seeing people's mobile devices or phones, pass by the entrance to a building. So I'm like, perfect. That's what I want to do. I want to prove they're on the network by taking a look at the data that's leaked out of your phone as it sits there and looks for wireless networks. And so that was kind of the crux of my idea here. Build a pattern of life sensor for transient devices at a static location. So again, transient devices being mobile phones, and a static location being that entrance to the building. Now again, there's some assumptions being made there, right? Those assumptions are everyone who walks through that door is eventually going to get on the network. Again, those are assumptions I can go ahead and kind of stock away for maybe another iteration of this problem. But initially, I just wanted to prove that people were walking through that front door with the assumption that they'll eventually get on the network in that building. So from the why, I transitioned to the design process itself. So initially, I wanted a small device that I could go ahead and just toss somewhere, right? So nothing clunky, something small enough to where I can toss in some bushes, I can set under a doormat, I can set around somewhere so it doesn't stick out, it's hard to see. But in doing so, there's a chance that someone may see it. So I also want it to be cheap. I want to be able to have it be disposable. And so if someone sees that and says, oh, cool, here's something with an antenna, I'm going to take it home and see what's going on with it, I'm out $20, which may or may not be a big budget, but if you're looking at pen testing or any sort of thing like that, it's really, that's not that much in terms of the price you pay for tools and some of the pre-made stuff out there. In addition to that, I wanted to be able to move the data that I'm finding, right? So just having that device at the front door of the building does me no good, because then I have to sit there. Maybe they'll see that USB cable run over to the bush with my laptop as I'm waiting for the data to come in, right? That doesn't look odd. So I need to be able to move that data wirelessly to somewhere else. So I need some long-distance communication vectors to go ahead and continue to solve this problem. Additionally, it needs to have low power consumption. Because again, I want it to be small and conspicuous. If I throw it out there at the 12-volt car battery, again, may cause some questions, raise some issues. So I want it to have low power consumption so I can put it on the least amount of battery power possible. And again, back to that, just kind of toss it in the bush, toss it in the corner, and it doesn't raise any issues. And then finally, once I've got the data, once I've backhauled the data somewhere else, I want to be able to centralize that data and then process it and do some aggregation against it, do that analysis to go ahead and look at it. Because again, we're looking at a lot of potential information coming back, so I want to bring it all to one area so I can look at it, or I can share it with others to look at it as well. So that was kind of the initial design process that I applied against this as I started to kind of work the problem. Then it caused me to build this neat little diagram right here. Okay, let me go ahead and just draw it out, and so I can visualize it, right? So I kind of broke it out into 3 different sections. I wanted to sense the data, I wanted to move the data, and then I wanted to present the data. And so once I did that, I was then able to think, okay, now I've got some smaller chunks to my problem to solve. I can solve the sensing piece, I can solve the move piece, and I can solve the presentation piece with different technologies and different approaches. And you see there on the bottom, the sensing piece identified, I can go ahead and use an ESP32 microcontroller for those particular sensors. And if you don't know what that is, I'll talk a little bit about it here in a second, so you can also we all level set our understanding of that. For the move piece, I identified that I wanted to do long haul, potentially low bandwidth, low power consumption communications. So I identified LoRa comms, or LoRa communications, LoRaWAN, right? Long range communications there. And then finally, the presentation piece. So again, like I said, I mentioned in my intro, I'm a Python programmer, by trade, and also, deep in my heart. So every problem in my eyes can always be solved with Python. So again, I could build a Flask website to go ahead and receive that data and then aggregate the data and present it back out. Moving on to the technology piece. So now that we've talked the design piece, I'm going to talk about the different technologies involved, and then kind of give you a little idea to kind of, like I said, level set our understanding of what we're looking at here. So initially, there were 3 technologies that I was looking to use. 2 that were new to me, and one was kind of old to me. The first one is the ESP32 development board, right? So a microcontroller board. The second was the LoRa communications, and then finally the old one, because I've done some work with alpha cards, I've done some work with wireless sniffing, the Wi-Fi piece to it. So the ESP32 development board, relatively cheap. It's an IoT-focused development board. It's dual core. Most applications you run on it only use a single core. It's got 4 megs of flash memory. It has Wi-Fi 802.11 BGN HD40. It also has dual mode Bluetooth. And then down there at the bottom, almost at the bottom, the power regulator is built in. So that was a key piece that I was looking for. So that allows me to use pretty much any type of battery I want. If you've ever worked with any small device before, you know that they are very susceptible and very susceptible to changes in power or to power that you're inputting into it. However, with this one, with the power regulator built in, I could put a series of AA batteries on there, it'd be fine. I could throw a 9-volt on there, it'd be fine. So again, I'm not restricted to providing it the exact voltage that it needs. I can give it more and have it still run. And then, of course, as with all things I like to do when I start off, I ended up buying the Cadillac of boards, right? So there's an OLED display on it, and then it had the LoRaWAN radio. So when I first built out the sensor, this is about the size. So again, it doesn't show up in there, but that little green box right there is the size of the ESP32 development board. So relatively small. The second technology. So again, that was the sense piece, this is the move piece. So LoRaWAN is a long-range wide area network, and it can push data approximately 2 to 8 kilometers, right, out of these little tiny radios. Now again, I say that with a little bit of a caveat there. It's still a radio, and it still has limitations, right? So terrain-based, so point to point, it can probably make that. You're trying to send data through walls, through buildings in an urban environment, your signal is going to degrade a lot. So just keep that in mind. But it can go approximately 2 to 8 kilometers. However, that long distance, you pay a price. It is low bandwidth. So depending on your settings and depending on the factors you apply when you first set up your LoRa communications, you can get as low as 300 bits per second all the way up to 37.5 kilobits per second, which is really not that much. However, again, depending on what you're trying to do with it. In my case, I'm just looking at packets and pushing a little bit of data. So to me, that wasn't that big of a deal. The LoRa technology is also interference resistant. So it uses what's called a chirp spread spectrum, which is really kind of a unique way for it to work against the interference. So every time it pushes out a little bit of data, it sends it out in little chirps, they call it. And those chirps maintain the amplitude, but then change the frequency. So the frequency will start off wider and then get closer as it gets to the end of the chirp. Then finally, LoRa is also low power. So as it's pushing that long range and the low bandwidth, it's not utilizing that much power to push it over that long range. So again, it allows you to maintain the battery life. In addition, the LoRa radios can also put the device into a deep sleep. So if it's not pushing any sort of information, it can then stand back and just go to a very, very low power consumption mode and maintain itself. Now moving on into kind of the problem decomposition piece. So the first part was the build. So when I say problem decomposition, what I'm looking at is, let me take a look at this difficult problem and try to decompose it into solvable chunks. Now this was a lesson learned. This was a kind of a hard lesson for me here because, again, as with some things I do, and maybe some of you out here do the same thing, I approach the problem with a little bit of hubris. I'm like, I've done this before, I've tinkered before, this is easy. Let me just go ahead and just slam all the code together, hit compile, and then try to load it to the board. Well, I put all the code together, I hit compile, and it failed. Failed with a lot of errors. And so I was like, wait a second, I've got LoRa communications, I've got Wi-Fi sniffing, I've got, HTTP post requests going on. Where is it failing? I don't know. So I took a step back. Instead of flipping my desk, took a step back. I'm like, wait a second. Let me get a little smart about this and build a better approach. So I did some problem decomposition. Sat down with some markers and some white, some paper, and just drew out the problem and said, okay, what can I solve first? And then I'm like, let me just do the Wi-Fi sniffing code first. Let me just build that simple, or pull that from somewhere else, because again, there's some repos out there where you can go and find these as solved problems. And so I built that out. I was just printing that out to the serial out on the board. So that way I can test and say, okay, am I actually seeing networks around my house? Perfect. Then I shelved that, and I said, okay, let me just get the LoRa radios talking to each other, or at least talking one way, sender receiver. Perfect. So I went ahead and found some example code for that, and then I just had to increment a simple counter. Packet sent, packet received. Boom. And again, nothing else, nothing more than that. And then worked that until it was done. Took that out, shelved it. Then I'm like, okay, let's figure out how to connect the ESP32 to Wi-Fi. Same thing. I had to connect to my access point. Figured out, perfect, very little small snippet of code, shelved it. And then finally, the HTTP JSON post request. So again, decompose the problem into several steps. And then once I was done with that, then we layered them, right? So then I'm going to do the sniffing code, LoRa comms. Works together, perfect. Sniffing code, LoRa comms, pushing the MAC address that I was seeing. Okay, still good. And then LoRa comms, pushing the MAC address, receiving it, and then building an HTTP request. And like I said, it was a kind of an incremental process. So that way, if something went wrong, I knew it was an issue with the code I had added since I had last updated. So I was good. Like I said, didn't have to flip a desk during that process. However, it did take a little extra time. And so just know that when you do any sort of problem decomposition, you do eventually, or you do extend the time you work to solve the problem. However, it pays dividends. On the next piece, in the build out, writing the code, I found out, hey, this is a little different process. I'm using Arduino Sketch. Has anyone here used Arduino Sketch before? I got a few folks out there, perfect. So again, you open a new file, and you're like, ooh, it's blank. But you got some curly braces in there, some mustache brackets, and you're like, how do I start? Well, if you take a step back and think, I cannot be the only person who has thought of this problem before. So I hit up the Google, search for ESP32 Wi-Fi sniffer, boom, GitHub coughed up a repo for me, perfect. And then I'm like, okay, how do I figure out the LoRa code? Again, the board I bought, the Heltec company, actually had libraries built in with their, once you updated your Arduino sketches, and then example libraries. So you can just go ahead, boom, pull them down and populate them into your sketch environment. The other piece that I learned too, and again, for those of you who are radio gurus or SMEs or whatever, I apologize up front, I am not. All I know is that the antenna has a direct impact to the transmission distance. Fair enough, right? However, I don't know if my antennas are tuned to the 915th megahertz frequency. I didn't know any of that. So that was that was on me, and that's something that I have to work to kind of get better at. But again, part of that build process was identifying that was a gap. It worked good enough for me. However, moving forward, I'll go ahead and try to work that a little better. So that was the build process. Now going into the collect piece, right? How do I go ahead and find those packets to go ahead and sniff and pull out the appropriate information that I want? So I fell on probe requests. What are some other, does anyone have any other ideas of what I could have been looking for at this point? Does anyone know the other data types for the management frames? No one? What's that? Clear to send, clear to receive. There's a couple there. Beacons, right? So there's also beacon packets. Have you heard that before? So again, this was kind of a decision that I had to make. Do I look for probes, or do I look for beacons? So again, this kicked off a little mini thread of research for me to go in there and look, and found some difference there. And I'm like, okay, so beacon, just for the crowd here, the beacon request is your device. I'm sorry, is the actual access point saying, I'm here, I'm ready to accept connections. This is my SSID, here are my settings. But think about my initial charter, my initial kind of problem though. I'm not looking for that, I'm looking for transient devices, devices that are moving. So I'm assuming it's a phone or some other communications device that they have on their body. I'm not gonna see any beacons from that. So then I kept looking, kept researching, and I found probe requests. So the probe request is your phone or your device saying, hey, I'm looking for an open access point, right? And there's a couple of different types of probe requests and a couple of different ways for them to do it, but essentially it can say, I'm looking for this device, or sorry, this particular SSID, is it out there? Or it can say, I'm looking for any SSID and let me know what's out there. So that's what I fell on. I started to focus in on probe requests, and I started scanning for probe requests across all the channels, right? So again, on Wi-Fi, you got multiple channels based on the country. And then as I broke it down, I looked at, hey, I want to go ahead and pull that source MAC. Because again, I'll talk a little bit more on the next slide of the frame, the breakout of that frame header. And I just want the source MAC because I don't need any other information. I just want to uniquely identify that device so I can prove that that device has passed by my sensor. And then once I identify that, I want to go ahead and package it up and send the probe source MAC and the sensor ID to the gateway. So again, the idea was for me to have multiple sensors potentially to set across different entrances of the building. So I wanted to uniquely identify that particular sensor as well. So I wanted to send that sensor ID with it. So here is the kind of the probe request breakout. So anytime you have these management frames that come across Wi-Fi, it has this particular format: frame control, duration ID, address 123, sequence control, address 4, and then some other stuff, QoS, so on and so forth. For this particular, for a probe request, it is a management frame of type 4, and what that means is adder 1 is the destination address, where it's sending it to. Adder 2 is the source address, the MAC address of what's sending it. Adder 3 is the VSS ID that it's looking for. So again, remember I told you there are kind of two different types of probe requests. One, it's saying, hey, I've seen this network before, I want to connect to it if I see it, or it's going to leave that blank, and if it leaves it blank, it essentially slits it's a response from the access point to say, here's my BSS ID. And then adder 4 is not used in this particular probe request. However, it's there for the other different types of Wi-Fi frames. So you'll see that used in other places. Moving on to the next piece, right? So once I've found the information I wanted to go ahead and move it to my destination. So for this, what I did is I established a point-to-point LoRa connection between two LoRa radios. And essentially, it was my ESP32 LoRa sensor to an ESP32 LoRa receiver, or the gateway I called it. And in my testing, I was able to get about 200 meters of distance before it would fall off. Now, just keep in mind, like I said, I am not a radio SME, and I'm pretty sure I had some antennas that were bad, and of course, I was probably fighting terrain, so on and so forth. About 200 meters, which is fine, because if you think about the scenario I built, throw the sensor at the front of the building, maybe sit out in the parking lot with my gateway and a laptop, or gateway and my phone, and then I'm receiving those LoRa packets and then pushing them up to where I need to aggregate them. So then establish a LoRa gateway, and I pass the data from the LoRa interface to then the Wi-Fi interface on that particular device. So again, hold these up a little bit. So this is my sensor that I can drop, and same thing, this is my sensor that then just receives it and connects to Wi-Fi and pushes the data up into my, my particular website. Then finally, the presentation piece. So again, built a Flash website, receive that data in a JSON format, process it. The biggest thing in this particular piece is I'm going to check to see if that ID is allowed. So again, if someone's able to figure out the system sitting out there, they may not have that particular sensor ID. So again, it'll just be, the website will receive it, it'll throw it out. Store the data in the database, and when it does that, it's going to conduct an OUI lookup. So essentially look for that kind of company information of the MAC address and add that information to kind of the database entry, and then finally present the data in a simple table format on the website. All right, so today I've been carrying around my device, and just kind of looking for those frames. And so here is my site as it sits. And so these are all of the probe requests that I've picked up so far. So someone's definitely spamming the airways. You see the top one there? I'm pretty sure that dead beef dead is not a legit MAC address. So someone's out there spamming it, which is great. That's fine. Well, you see what I've done here. So you see the MAC address. I put the time that it's last seen. Now, again, that was kind of a guesstimate on my part because it's the time it hits the gateway and is stored in the database. And then the count, the number of probes it's seen, the actual lat long. So again, that's set statically on the website itself. The sensor ID, and then it doesn't, like I said, it does an OUI lookup. And so look all the way over there to the right, a lot of Cisco. Makes sense, right? You look up above you, I'm pretty sure we've got some Cisco access points hanging around somewhere. A lot of Cisco in this building. So it makes sense that we have Cisco. However, that's not what I'm looking for. I'm looking for those phones that are out there potentially, right? So still more Cisco. Still more Cisco. Some Motorola, so there's a neat one. But again, let's go all the way down into the bottom. So once we come out of this demo, we'll start talking some lessons learned. And it was a hard lesson for me to learn here, right? So I have 11,180 unique entries in my database. I'm fairly certain that there have not been 11,000 devices that have flowed through here since this morning. Fairly certain. So again, why could that be? Why am I seeing 11,000 unique OUIs? What's that? Possibly. That's a good one. So the answer was multiple radios. But let's think about it. They sold 500 tickets here. Even with multiple radios, I would expect to see maybe a couple thousand. Answer. So reconnection of the same device. But think about it. If it's connecting, the MAC address should stay the same, right? That source MAC. What's that? So possibly, but again though, that MAC should still stay static in the back there. Boom! Thank you. All the way in the back. I got a book up here for you. So if you didn't hear the answer was me not dropping my microphone. Thanks. All right, so if you didn't hear the answer was in recent OS updates to Windows, to Mac OS, to Android, to iOS, they have all implemented a feature called Randomized Mac Addresses, specifically for probe requests. And they've done that, and here's the kicker, they've done that to combat exactly what we do here, to a T. So I think my computer's. But yeah, so randomized MAC addresses. So if you go through this list, you will find, and I've got a data set from my house, that the OUI will change, but the actual unique identifier for that device will stay the same sometimes. So again, a lot of analysis there. But what that does is it kind of took the wind out of my sails, if you will. I'm like, I had this fantastic idea. I'm crushing it. I'm tinkering, I'm making things, and I'm like, what are these things that I'm seeing that I should not be seeing? And that's what I came upon. My buddy was like, hey, because again, I have a Slack channel with some friends, and they're like, hey, take a look at this. Boom, throws me a link, and I'm like, yep, that's my problem now. So it was a lesson to learn. So let me go back here. Hit the presentation. All right. And continue on. So lessons learned, measured in OOF levels, right? OOF cubed, or the oof is the Mac randomization for pro request was built to combat exactly what I'm trying to do here, right? So keep that in mind. Mac randomization just for pro requests. Now, again, every OS implements it differently, and you might have seen that if you went back and look at my data set. There are some that had no OUI that was identified, but it had a bunch of packets, and then all the way down to the bottom of the list, I had several thousand that are just a single packet at a time. So again, that kind of boils back to the number or the way the OS implements that Mac randomization. So another oof cubed was please share and discuss your code. I understand wholeheartedly that that is easier said than done. No one more than I understands that when I write code, it's a very personal thing. I don't want to share that with anybody. Why? Because it's an iterative process, right? I've learned early on through many hard lessons that I don't delete any code until I'm finally ready. And even then, it's an emotional event. I comment it out. Or I put it in another file. I stock it away for later because you know what? There's a good chance I've messed up somewhere. I know I have. I don't write code well. However, the only way to get better at writing code is to share it with someone else. Do that left seat, right seat ride. Do that over-the-shoulder programming, the pair programming, whatever you want to call it. Do that because, again, if you don't, you will run into confirmation bias. You will run into the fact that, hey, I wrote this code. There's no way it is bad. Two lessons I learned here, or two specific examples. As I was going through, I was writing my website in Flask. I had version control going. Sweet. Writing my Arduino sketches, I did not. Because you have to have all your files in one location. It was a whole thing. It seemed like a bridge too far. I hit the easy button. I'll just have it on my desktop. Perfect. Then I went in, I was making some changes. This was when I was doing my Arduino my LoRa to LoRa communications. And so I had to set the actual frequency it was talking on. Then I had to set the bandwidth. The frequency was like 915 E6. The bandwidth was 250 E3. Now, if you write code in an editor, it's typically courier type kerning, right? So standard kerning, everything lines up. On one, I'm going, sweet. Save, compile, upload, it works. Same on the other one. Save, compile, upload, it works. However, none of the counters were incrementing. Like, wait a second, it was just working yesterday. What is going on? So then I start stripping out code, right? At that point, I'm just mad, right? I violate my own principle, and I'm just deleting code. Adding code, deleting code, adding more code, deleting more code. And what I found that I had done, and I would have found this faster, it took me about a day and a half to figure this out. I found out what I'd done is I set my frequency to 915, I think E6, and my bandwidth to 250 E6 on one, and then 915 E3, or E6, and then 250 E3. So the bandwidth wasn't matching up. So one was talking the right way, the other one was not listening the right way. Now again, as that code lines up, everything looked perfect, right? It's very hard when staring at two different editors to see the 6 and a 3. And so again, I'm ripping code out, I'm destroying it. And finally, when I came back the next day, and I sat down, it was right there, right? Now, if I would have asked someone else to look at it for me at that moment, there's a good chance they probably would have found that. You know, probably gave me a hard time about it too, but hey, that's the life we live. So please, that's one example of sharing your code to get some help. The second example that I ran into. So I mentioned in my design process that I was doing an OUI lookup, right? On my Flask website, fairly simple. I had a large JSON file that I'd load up one time and then just do lookups on the fly. And then as my sensor was sitting there talking and looking, website was getting slower and slower to load. And then all of a sudden, I went to bed one night, woke up the next morning, and I hit refresh, 3 seconds. I counted it. 3 Mississippis from a website to load. I'm like, man, am I that bad at website design? And I'm like, well, Josh, yes, you are, because you don't do web, you do Flask. And so then I'm like, am I that bad at Python? I'm like, man, it can't be that. It can't be that. I kept looking, and it kept going. I'm like, there is something I am doing really wrong here. Could not find it. So again, called in my buddy Zach. I said, hey, please take a look at this. It's loading, it's taking forever to load. It took him 30 seconds. He looked at my code, he's like, yeah, good job there, buddy. How about this little lookup right here? I'm like, the lookup's fine. I mean, I'm just doing an OUI lookup. He's like, correct. That was fine when you had 10 packets. You have 100,000 packets now. And you're doing a JSON lookup every refresh of your website for every single packet. I'm like, oh yeah, that's an oof cubed right there. He nailed it. So again, what I had me do is go back and refactor, added a new column in my database. So I did one lookup the minute I saw the packet, stored it with the OUI, problem solved. So again, hard lesson learned for that. So here's an oof squared though. Take time to develop your design first, right? I know we talk about it. I know if you've had any sort of design class or any sort of programming class or anything like that, they've told you, hey, sit down and just maybe whiteboard your idea. Sit down with a piece of paper. It doesn't have to be fancy. And just do that. However, if you're like me, you're like, you know what? Design, I'm going to jump in head first. I've written code before. I've stood up a website. This is too easy. So you dive in head first. Sometimes you don't realize that's a shallow end. And that's what I did here. I mentioned it earlier in the talk. Right? I jumped in. I'm like, I'm going to throw all my code on my editor at the same time because it all works separately. So why shouldn't it work together? Boom. Ran into the huge issues, right? And I didn't even know where to start because, again, it started throwing errors. And, again, compiled code is always funny because it'll find that first error, and you don't know what's followed, so you got to fix that one, and then it's an iterative process. So, again, just take time to develop your design first. The other oof squared that I have is use version control, right? I already mentioned about my Arduino sketches. Ran into that the hard way. It was rough going. It was a hard day in the Josh household that time. Because when I was done ripping out code and replacing code, and then I switched that 6 into 3, I then realized I had a follow-on problem. I don't know how many deletions away from my original product that worked, right? We've all been there. And if I would have been using version control, it should have been, a revert. It should have been just a quick lookup in my Git repo of the submits or the commits I had, and just to switch back to a known good version. So again, use version control if possible. The final lesson learned is just a simple oof, right? But do not be intimidated by hardware. I know it's a lot easier for me to stand up here and say that because I've tinkered with it a lot. However, it's a very mature space at this point. If it was maybe 15 or 20 years ago, and you're looking at an Arduino and you have to write, embedded C code just to get that thing to work, it's a rough go. However, there's a lot of examples out there, to start from that are mature libraries, mature examples, good places for you to start. And like I said, I've got a couple in mind that I've used to start from, and then you go ahead and take that and you deviate from that path and you keep going. And again, so don't be intimidated by the hardware. It's not that hard. And again, you can learn as you go, right? The biggest thing is just jumping in and figuring out what you need to learn by using those libraries. All right, so now, like I said, I failed. But again, there's success and failure always, right? So again, when I failed, I now know that so at the end of the day, I know that this does not work. And I validated that doesn't work, right? So I consider that a success. However, I still want to continue down this path. So I think for my future work, this is where I'm going. So instead of focusing on probe requests, I'm going to go ahead and shift to see if I can do Bluetooth sniffing. I should be able to kind of transition that, like just rip out that Wi-Fi sniffing code and replace it with Bluetooth sniffing. So again, I'm making an assumption that it's going to be easy, but we'll see. But that's where I'm going to move towards for at least the sniffing part and identifying the unique devices. I also want to refactor my code. So I wholeheartedly acknowledge that my code is not the best code at this point. There's no comments. It's hard to read. A lot of the code has been commented out, and there's different versions of the functions and whatnot in there. So I need to go ahead and fix that. Also, you saw my website. Very simple, just a table organized by number of packets it's seen. So I want to apply some analytics to that, right? It's a Flask website. Should be easy to build some additional routes and do some analysis there. So that's where I'm going to go for that piece. You also notice that I only capture the date of the last packet seen. So I want to go ahead and add some timeout logic, right? So if it sees it, one time and doesn't see it again, maybe it throws a flag on the website. I don't know, because again, at the end of the day, if you look at what I've completed, I can only prove that someone has gone into the building. I can never prove when they've left or if they're still in the building. So I want to build out some logic there to kind of identify that, or at least clue folks into like, hey, I haven't seen this particular packet, you know, in X amount of time. There's a good chance they've left the building. And then finally, I want to refactor my design onto a smaller board. So right now, like I said, I've got the Cadillac of ESP32s. It's got the OLED display. It's got, you know, it's got everything on it. However, I don't need that display. It was nice for troubleshooting, but now that I've gotten to the point where it seems to work, I can go ahead and find a smaller board that doesn't have the OLED display. I don't need GPIO pins, so I don't need that general purpose IO pins on there. So again, working myself to get down to a smaller board. However, the whole purpose of that is to get down to lower power consumption, right? I want that sensor to run on the least amount of battery power possible. However, so with the Heltec, just to give you a little bit of an idea though, that device has been running on 3 AA batteries since 6 o'clock this morning, and it's still going. So it's already got pretty low battery consumption. I haven't tested it fully yet, but I want to continue to push the envelope on that because maybe it becomes a multi-day affair. Maybe I throw it and I leave it for a weekend or for a week, and I want to come back to it. So again, that's kind of, I want to refactor that design to get to a lower power consumption on the board itself. So at this point, I've released both of my GitLab repos out there in the wild. That is my commitment to everyone here, because again, share your code. I'm saying it right now. You can go look at it. If you want to poke fun at me, please, I'm on Twitter. Please tell me how bad my code is. But I've got two repos there. One is the Flask website with directions on how to stand it up and how to get it going. The other one is the actual LoRa code for the ESP32 boards, both the sender and the receiver, kind of in both of those repos. Again, name's Josh Rykowski, Ryko212 on Twitter. Email there at the bottom, ryko212@runcode.ninja. Feel free to hit me up, let me know what you need, any questions you have. But I just want to open up the floor to any questions about the research or anything I presented here today. Yes? Okay, so just to recap for everyone, if you didn't hear the question, he's asking me if I chose the ESP32 board specifically for the LoRa communications on it, or could I have gone another route with the ESP8266s and then use it in kind of a mesh network to get the same functionality. So I started off with the idea of doing long haul communications. So that was that 2 kilometers, 8 kilometers piece, right? I wanted to be able to possibly, you know, be very physically separated from the devices. That's where I started. However, you know, again, at the end of the day, when you start applying that middle piece of that design slide that I had up, you can put anything in there, right? I could have left it Wi-Fi and then been within 100 meters and then just push it over Wi-Fi to the device. So a lot of different solutions there. I just was trying to get that longer term, never got there, probably because my antenna tuning and whatnot. But yeah, that's how I ended up with the 32, though. That was a great question. Thank you. Any other questions? Oh, yes. Any other questions? I've got a brand new alpha card up here. Yes. Wow, that is a fantastic question. I appreciate that, and sure. Boom. What's going on, man? All right, any other questions? Like I said, about this, anything I've talked about? Oh, yes. Wow. Great question. Okay, so the question was, before I dive into this one, the question was, hey, he knows I love Python, and he knows I leaned on that for Flask, but then he threw me a curveball and said, hey, did you think about writing everything in C? The answer is no. And let me tell you why, right? So again, having programmed as long as I have in Python, I've been doing this since 2009, writing Python code. making that switch back to the Arduino sketch and C++ format was a very emotional event for me, right? Because I'm thinking, okay, you know, I'm gonna do some quick lookups on the MAC address. I just want to do the membership operator, right? In Python, that's easy. I want to see if the letter A is in a string. Is A in string var? Anyone know how to do that in C? Because I don't, right? It's literally, I'm going to iterate over all the characters. Wait, I'm going to take the string var, push it into a buffer, iterate over that buffer, and when I find it, I'm going to stop and say true. If not, it's going to get to the end, the null terminator, and say false. And that just took my one line of Python to, well, by the time I'm done with it, right, multiple versions, it's going to be down here. Fantastic question, and yes, if I'm looking for, what's that? Your memory buffer? Yes. Correct, exactly, right? But you know, at this point, and I try to tell folks the same thing oftentimes, and I'm guilty of it as well. If all you have is a hammer, all you see are nails. I'm comfortable with Python. That's why I've gone in there, and I've seen people do a lot of things. But you're exactly right. If I were to sit back, you know, write that in C, I would definitely see a lot of optimizations and a lot of efficiencies once I got over the hump of hating my life for 4 months. Yes. Great question, though. Thank you. Any other questions? Yes. So the question was, he's seen some folks use MicroPython and regular Python, and he asked me if I've looked into MicroPython. So is MicroPython the Python that they use on embedded devices? Okay, yeah, so that is a possibility. So I haven't looked at it before. I mean, I know it exists, I know it's out there. I'd have to go look because I'm making some assumptions here, but because of the amount of memory you have on those embedded devices, it cannot load all of your batteries included modules of Python in there, so it might not bring everything with it. That is definitely a path that I can look at to see if MicroPython would carry a lighter load and then allow me to write Python code on my ESP32. That's actually a good point. Only bring in, okay. Yeah. Yeah, no, and that makes sense, right? And just so everyone can hear and recap what he said, so what it sounds like is when you write your Python code for this embedded device, it compiles it down to the embedded device, pulling the modules it needs only for that code to run in there, so it makes a small footprint. Okay. Yeah, that's definitely a good path forward. I have to take a look at that and make some things easier. But yeah, thank you for that. Yeah, that's Adafruit's library. All the way in the back, Nick. In terms of, okay, so the question was, did I write any of my own custom modules or did I use existing code? For all of this, it was existing code, right? Just manipulated it in certain ways, understood what it was doing, commented out some stuff I didn't need. So for instance, the Wi-Fi sniffer code that I found, it was actually pulling and printing all three of those adders. So if I go back here to the format, it was printing adder 1, 2, and 3. So again, I didn't want the destination address. I didn't want the BSS ID it was looking for. So I just wanted that actual source address. So I commented out address 1 and 3. And in fact, if you go look at my code, it's literally listed as adder 2 in there, and I've commented out the other 2. So I didn't actually I just worked with the code that I had. So you kind of hit that easy button there to get to the solution to this problem, though. It's a good question. Thank you. Anyone else? That's it? No more questions? All right, so I'll just close it out with thank you for your time. I do appreciate it. You know, see some friendly faces out there. I do appreciate it. See some new faces out there, so thank you for spending some time with me this afternoon. You've got my contact information, so if you have any questions and you don't want to raise your hand here, or if you have that epiphany, tomorrow morning at 2 in the morning, you wake up, you're like, oh, I want to ask him this question. Again, hit me up on Twitter, hit me up on that email I got on my page here, and I will definitely get an answer back to you. It may not be right away, got a lot of stuff going on, but I will get something back to you if you do have any questions. Other than that, I do appreciate your time. Thank you.